We're going to start up here with 6-1 as an introduction for 7-1 and a couple of our units that are coming up. So our exponent properties basically work like this. If you're multiplying together two bases that are the same, and let me stress that, your variable, your number, whatever this part is, has to be the same for you to be able to put these together. So for instance here, my rule is, if I'm multiplying, I add the exponents together. So 5 and 6 gets me x to the 11th, not x to the 30th. Okay? When you're multiplying, you add exponents. Again, whether it's a variable base or a numeric base, you have to add those. However, if you go what's called power to power, which is exponent to exponent, then you do multiply the exponents together. So if I had x to the 5th to the 6th, it would be x to the 30th. Because if you think about it, what really is x to the 5th to the 6th power? It's x to the 5th 6 times. Now, nobody wants to write that out 6 times. I don't like doing it right now. But just to let you see where it comes from, 5, 10, 15, 20, 25, 30. Okay? I just multiplied them. Yeah, instead of having to write all those out a bunch of times, which I do not want to be doing. Okay? The rule there is multiply. If you have a power of a product, if you have more than one variable term inside the parentheses, you just distribute that parenthesis, that exponent through. So this 3 will go to the x, and it will go to the y. So I'd end up with x to the 3rd and y to the 3rd. Negative exponents. We don't like negative exponents. They have bad attitudes. So like what some of you may do if you have younger brothers or sisters, they get out of line, you just grab them by the feet and you tip them upside down, and then all of a sudden things kind of change. Okay? Their attitude changes a little bit. We're going to do the same thing with an exponent here. Anytime you see a negative exponent, and it's not in a fractional form, you need to think about it that way. Because when I go to flip it, if I don't have a fraction, I tend to just change the sign and think I'm fine, but I'm not. So this x to the negative first would flip to the denominator, and then I'd have a 1 on top. So I'd have 1 over x to the first. It would be its reciprocal. It works the same way if it's down in the denominator. If it's negative in the denominator, we flip it up to the numerator. And you may be saying, do I really have to have this 1 here? No, but, again, for those of you that are creatures of habit, I've seen it happen often enough. When I don't put this one in, then people think they don't need this one. And this one I do have to have. So I just think it's easier to leave it that way. 0 exponent property. Anything to the 0 power, okay, except 0, is 1. It's a variable. X to the 0 is 1. It's a number. 8 to the 0 is 1. The only exception, which we're going to put on here, let's say you had, not in parentheses, negative 8 to the 0. In this case, 8 to the 0 is still 1, but since this wasn't in parentheses, yeah, what I'm actually doing is I would multiply the negative later. So that's the one exception you have to be on the lookout for. Now, if that negative 8 were in parentheses, it's still just 1. And the calculator can even help you on that if you're not sure something. Here's where you might hear something new from me. Quotient of a power. Okay? Normally, you just do numerator minus denominator, and if the denominator is bigger, it's a negative, and then you flip it. I don't like that. So here's what I always tell people to do. You need to do the larger exponent minus the smaller one. I don't care if they're in the numerator, denominator, doesn't matter. Do the larger minus the smaller, because if you do, your answer goes with the larger exponent. So instead of having to play this big game with all of these negatives, instead of having to screw around and say, oh, that's negative, well, now I got to flip it. Well, I have to put it over 1? I'm not sure. you can just say, okay, larger minus smaller. So 8 minus 5 is 3. Where's the larger exponent? It's in the numerator. So I just get x to the third. But when I get to the next one, 7 minus 4 is 3, but where's the larger exponent at? The bottom. So my third power with my b goes at the bottom. Keep life simple. Okay, so when it comes to dividing with exponents, larger minus smaller, and put the answer where the larger exponent is going to be. And final, power of a quotient. If I have an exponent and I see a ratio or something with division inside, that exponent goes to every piece inside. So I've got x to the fourth, y to the fourth. Now once I get rid of the parentheses, can I subtract my exponents now? No, why not? Right, I don't have the same base, they're not the same variable. This is as far as this one goes. So sometimes you just have to stop. It just happens that way. So when you actually get into working some of these, bump this up a little bit here. Division, what do I do with the exponents? Subtract. 12 minus 5 is 7. Larger exponents on top. I get x to the 7. Now you have a choice on the next one. I notice on the next one I have these x's and I'm multiplying. So what do I do with the exponents when I'm multiplying with a like base? Add. So 4 plus 5 is 9. But I have a choice on the y's. I'm still multiplying, so I still could just add the exponents. Negative 1 plus 8 is 7. Some of you may say, but I thought when you have a negative exponent, you flip it. You could. But then you'd have to go back through, and you'd have 8 over 1, and you just subtract, and still end up with 7. So again, the fewer rules you have to deal with in a problem, the easier it's going to be, and the better off you're going to be. Here, I have an exponent outside. It goes to the x and to the y. X to the third, 2 times 3 is y to the sixth. So these are going to have to be properties that you are familiar with. I have an exponent on the outside. It goes to the 3. Even though I don't see an exponent on the 3, there's a 1 there. I still go with that. And to the 3, and to the negative 2. So here's what I'm going to do. I've got 3 squared. 2 times 3 is 6. 2 times negative 2 is negative 4. Anytime I see a negative exponent, once I've done a step, I'm going to automatically turn this into a fraction. And here's why, again. I know with negative exponents I have to flip them. So let's see. 3 squared, well, that's a positive exponent. That's 9. That gets to stay. X to the 6 still has a good attitude. It can stay up in the numerator. Y to the 4th needs an attitude adjustment. Y to the negative 4th is going to get flipped down to the denominator where it gets a better attitude, and I'm done. And that's the kind of realm we're going to be dealing with on these. Several rules to work with, but it's just about getting things simplified. X to the 4th, y to the 3rd over x to the negative 3rd, y to the 0. Now for some of you, this can become an issue. You can either, I'm actually going to split this one off because I want you to think about it 2 ways. If I just follow the rules, I do the greater minus the smaller. So what's 4 minus negative 3? Okay. Yeah, I was going to say 7, and that's one of the reasons I'm going to show you the next way of doing this. 4 minus negative 3 is 7. My larger exponent's up top. 3 minus 0 is 3. Larger exponents on top. Here's what I would suggest quite a few of you do. If you have that negative exponent, So you're like, okay, I got x to the fourth, that's fine. I got y to the third, that's fine. X to the negative third. I'm going to flip that up to the top before I do any transactions here. Because that way, y to the 0 is fine where it's at. Now, when I go to look at this, I can say, okay, I've got x to the fourth and x to the third. They're both up in the numerator, so I'm just going to add the exponents. 4 plus 3 gets me x to the 7th. And I still do 3 minus 0, which is 3. I get the same answer, but I'm not having to deal with the negative exponents, because I know sometimes minusing that negative or something is going to throw some of you for a loop. So be cautious. Be very, very cautious. Next one, again, when you're dealing with coefficients, these are not exponent rules. We still deal with those like we normally would. 25 divided by 5 is 5. Okay, don't change that at all. This is me personally again. I'm looking at this and saying, okay, x to the 7th, ooh, I see x to the negative 1. I'm going to bring that up. Does it take me an extra step? Yes. But am I going to avoid that dreaded problem with the negative? Absolutely. And the y's are all good the way they are. Now that I've simplified that, now I'm ready to get down to business. So let's see, I got the 5. All of my x's are up here now. So I'm going to add the exponents. 7 and 1 is 8. And then I'm dividing. I'm going to subtract the exponents. 8 minus 2 is 6. And the larger exponent is in the numerator. I'm done. I didn't need my fraction bar, so I'll just use it as part of my circle. But that's the drill here. Same thing going on here. 12 over 8. This does not become 1.5. If it's fractional, reduce the fractional part. I can divide each of those by 4. Okay, but then leave it alone. Oop, x to the negative 5th, that needs to flip. Y to the 7th is fine. X to the 6th is fine. Y to the 4th is fine. I'm going to do my flipping first. Because now, I can look back and go, okay, y to the 7 over y to the 4, 7's bigger. 7 minus 4 is 3. 5 and 6 with my x's are both in the bottom. They're both positive. I'll add those up. That's the 11th. Happy, happy day. Last one I'm going to take a look at here, because the bottom ones kind of start to repeat. We're going to split this one. If I just go with what I see, and I'm going to distribute this negative all the way through, so the 2, x, and the y down below. So 2 to the negative 3rd, x to the negative 3rd, y to the negative 6th. Because again, I'm multiplying with power to power. Shoot, everything gets to flip, because everything's negative. So that y to the negative 6th will go up top. That x to the negative 3rd will head to the bottom. And again, I'm going to stress this. 2 to the negative 3rd does not equal negative 6. It does not equal negative anything. It just means that 2 to the 3rd flips to the bottom, and 2 to the 3rd power is 8. So I end up with y to the 6th over 8 x to the 3rd. Again, it's detail issues. Okay? It's having a feel for these exponent properties that are up here, and if you're not sure, going back and looking at it a bit to get used to these. But again, there's no homework directly related to this yet. Okay? It's just kind of getting you used to things, because when we switch over here to the other sheet that you hopefully picked up once, what you're going to notice is there are going to be exponents involved again. Because 6-1 and 7-1 go hand in hand with each other. So, we're going to let the calculator help us sum here, but we're going to help ourselves out most of all. So, roots and rationals. Sometimes you can't punch some of this stuff into the calculator as easy, so we're going to turn it into an exponent form. So here's basically how this works. Whenever you're dealing with a radical, the little number that you see out here, which we assume is a 2 if we don't see it, okay? And actually, let's make note of that. We're going to assume that this is a 2 if I don't see a number there. Yes. My exponent, I'm going to assume, is a 1 if I don't see something. And when I go to turn something that's a radical into an exponent form, it always is going to be the exponent over the root number. So for instance, if I'm looking at number 3 and I want to turn it into a fractional exponent because I want to do some other function with it, it's always exponent over root. These are the 2/3. I'm done. Okay? Nothing to calculate, nothing to crank out, nothing fancy. Just put it in. Okay? E, what's my exponent going to look like on number 4? Ooh, nicely done. You've got a step ahead of me even. You're like 2 over 4. It's exponent over root. But I can reduce the fraction. 1/2. And we're going to do this exponent over root. But always reduce. Exponent over root, but that reduces to 10 to the first or just 10. So it's just like any time you deal with a fraction in algebra. If you can simplify it, if you can reduce it, you need to. Ooh, what about that last one though? Kind of nasty. Do each part individually. Exponent 2 over root 3. F, what's that one going to look like? Yeah, there's a 1 there. I assume there's a 1 if I don't see it. So 1 over 3. Different bases, I can't put them together. Different exponents, can't put them together. But I'm just going to write them out that way. Now I need to be able to go both directions with this. So consequently, if I want to write these as radicals, my base will always be my big number, so my 2's right there. But this is still exponent over root. Exponent over root. Now some of you are saying, couldn't I just write the square root of 2 if I assume that's a 1 and I assume that's a 2? Absolutely. But again, I think so many of you are creatures of habit that it's probably just going to do you better to keep doing the same thing each time. Exponent over root. So the 3 is inside with a, the 5 is my subscript in my radical. Exponent root. Now some of you may say, now if it's a number and I can simplify it, should I? You can. I could call this the 5th root of 25. That's what 5 squared is. Absolutely. For right now, no. Just you understanding that that goes in that way is fine. Exponent root. And you're just like, all right, exponent root. Doesn't change the order that those things work. So you're like, okay, so why would I necessarily want to be able to do this? What's the big deal? Especially when I could just plug 3/4 these things into a calculator. Well, let me tell you. And I know some of you will do this anyway, even though I'm going to give this warning, but I'm just going to keep telling you. When we get to quizzes and things, you're like, I could punch 9 to the 3 halves in my calculator and get an answer, and you're never going to know what I did. That's true until we get to the quiz and I say, show me a step or there's no credit. Because you're going to have to get to a point, especially when we get into variable terms, where you're going to be able to need to do this to reduce things. You need to start practicing now. Now, go to the calculator to check your answer. All good. But using it for everything, not quite so good. So here, turn it into a radical. Exponent over index. Now here, I'm not expecting you to know what 9 to the third is off the top of your head. It's 729. Now, if you want to go type in on the calculator, square root of 729, and get the answer is 27, I'm fine with that. Okay? That's what we're kind of looking for here. Now, here's something else you may look at. You're like, ooh, a negative exponent. Fun, Harty. Let me show you another way you can write this. Always looking for ways to simplify things. Yeah. Here, it's assumed that it's there if I don't see one. I could, but just like if I had like x as my answer, if I didn't put x to the first, there's one and the same. Same thing here. Whether I have that 2 there or I don't, it's still assumed that it's going to be there. So either way is fine on that. That gets the same answer. So some of you are like, ooh, now what are you doing, crazy man? I can also choose to put my exponent out here. You're like, well, why would I do that? Here's why. If you're like, ooh, now you're really getting odd. 32 to the 1/5, if I put that in the calculator, is 2. How do I fix a negative exponent again? Flip it to the bottom. This is a fraction, it's over 1. It's going to be 1 over 2 squared, which is 1 over 4. We're basically becoming puzzle makers, is what we're doing. We're taking the mystery, and we keep turning it and twisting it until we get it into the shape that we're looking for. Sometimes that'll be really easy to do. Other times it may not be so much. So for instance, here, I've got 4. Here's my exponent. My root is 2, so I don't have to write it. So, okay, what's the square root of 4? 2. 2 to the negative first, I just have to flip it. You have to be patient and take these in steps. Because if you do, a lot of the time, say 16. My exponent is 2. My root's 5. Now, you may not know, right off the top here. Oh, is somebody going to say something to me here? I'm actually doing something on purpose for once. Do you see anything wrong with this? Ah, okay. Why is the 2 on the outside? Because that's where my exponent is. Which one of these is my exponent? The top one. I'm trying to see if some of you are paying attention to what I'm doing. Okay. When you're writing these, notice we've been saying it's always the exponent's the number on top, the root's the number on the bottom. What did I do originally here? I flipped them because I wanted to see if anybody was paying attention. So, let's do this the right way. My exponent, and there's my root. What's the square root of 16? 4. So my answer is going to be 4 to the 5th. This is 1,024. I just wanted you to see how easy it is if you go too fast and you're careless on how these can get tough all of a sudden. Okay? One last one. 27 to the negative 2/3. Again, 27. My exponent is the negative 2. My root is the 3. Anybody know what the cubed root of 27 is? What's the third power of 27? 3. But I have this negative exponent, drat. 1 over 3 squared is 1/9. If you haven't, and we're going to talk some more with this tomorrow. You'll notice at the bottom of this sheet, there's not anything written as far as in the book type work goes. So here is what I want you to do. We're going to kind of split this a little differently than I was going to originally. If you take this sheet and flip it over to the back, okay, we are going to talk about this tomorrow in a little more depth. What I want you to do right now is I want you tonight to knock out the back. I'll be honest, okay, this is not going to be anything bad. Actually, what we just did in 13 through 17, I'm going to hold off and do tomorrow with you guys. And have you do some of them in class with me, and then I'll have you do the rest. The back of this needs to be done because you need to be able to make the conversions back and forth to make this easier. Okay? So if you went ahead and you were jotting down the book thing, don't worry about that tonight. We'll do that tomorrow. The back of this has got to be done.